Welcome to our lecture online. Here we have another example of how to solve a distance, velocity, time type of problem. We're going to rely on the new general method that we've learned. And the problem reads as follows. Jim's boat can travel 12 miles per hour. The river flows at 4 miles per hour. How far can Jim travel downstream when he needs to be back where he started in 6 hours? So he knows he only has 6 hours. How far can he make it downstream, then come back to the same place where he started and have 6 hours elapsed? So you can see here that at first the boat will go with the stream, 12 miles an hour for the boat, 4 miles per hour for the stream. It will travel a certain distance. We don't know what that distance is. We need to figure out what that is. Then he turns the boat around, starts coming back. The boat can go 12 miles per hour, but now he's going against the river that flows at 4 miles per hour. There's again several ways in which we can solve this problem. However, let's pick one of the ways, and since we don't know what the distance is, we can probably start with the equation distance 1 equals distance 2. And of course, since we don't know what the distance is, we need to eliminate that by replacing it with v times t, velocity times time. So we have velocity 1 times time 1 equals velocity 2 times time 2. So let's first replace the velocities. On the way out, he's traveling with the stream. So the total velocity will be the velocity of the boat plus the velocity of the stream. So in this case, v1 will be 12 plus 4, and we multiply that times t1. On the way back, the boat is traveling against the current, and therefore the velocity will be 12 minus 4 times t2. But here we still have a problem. We also don't know what the time is, but we know the total time. The total time should be 6 hours, which means that t1 plus t2 adds up to 6 hours, which means that t2 is equal to 6 minus t1. In other words, we could replace t2 by what t2 is equal to in terms of t1, and then we'll have one variable to worry about. So here 12 plus 4, that gives us 16 times t1 is equal to 12 minus 4, which is 8 times t2, but t2 can now be replaced by 6 minus t1, and all we have to do now is solve for t1. Getting rid of the parentheses, 16t1 plus 48 minus 8t1, bringing the 8t1 over becomes a plus. Oh, wait a minute. I should have an equal sign here, not a plus sign. So 16t1 equals 48 minus 8t1. Now moving the 8t1 over, we get 16t1 plus 8t1 because the sign changes when we cross equal sign equals 48, or 24t1 equals 48. Now all we need to do here is divide both sides by the numerical coefficient of t1. And so we have t1 is equal to 2. In other words, t1 is equal to 2 hours. So it takes 2 hours for Jim to travel downriver. And then 6 minus t1, 6 minus 2, right? So this would then be equal to 6 minus 2, which is equal to 4. That gives us the time for t2. It'll take 4 hours to go back, for a total of 6 hours for the trip. And now that we need to know the distance, we can then say that distance 1 is equal to velocity 1 times t1. The velocity going with stream is 16 miles per hour. t1 is 2 hours, so that's 32 miles total for distance 1. And of course, distance 2 is equal to v2 times t2, and v2 will be 8, and t2 will be 4, and sure enough, that's also 32 miles. It better adds up, and so you can see that distance 1 is indeed equal to distance 2. It's a good check, and the solution is that he can travel 32 miles downstream before he has to turn the boat around and start coming back, and that's how it's done.